If you're running aluminum casting trees through a bandsaw today, there's usually an operator manually feeding heavy parts toward a rotating blade. And right after cutting, each separated component is going to a belt sander for cleanup. The process can be efficient, but it exposes operators to safety risk and adds a second manual finishing step. PushCorp has spent more than 30 years helping manufacturers automate high-force material removal applications. This includes grinding and cutoff processes in foundries. In this demo, we evaluated how a robotic saw could handle gate removal on lost foam aluminum castings. We also considered whether it could reduce operator exposure while improving consistency. We produce robotic automation videos focusing on grinding, sanding, polishing, deburring, and other material removal applications. Please subscribe to see the many projects we have coming up. As you watch this video, leave a comment with any questions you may have and give it a thumbs up if you enjoyed the content. Let's now walk through the casting configuration, the tooling approach, the cut strategy, and what we learned from testing. The parts in this project were aluminum lost foam castings arranged on a tree. In the lost foam process, a foam pattern is embedded in sand and then replaced by molten aluminum. This produces a connected structure of finished components attached to gates. Once solidified, each component must be separated from the tree before it can move downstream. In many foundries, this separation is performed on a large bandsaw. Although the process can be fast, it places hands and upper body in close proximity to the cutting zone. The objective of this demo was to evaluate whether a robotic cutoff process could reduce operator exposure to the bandsaw, maintain throughput, and move closer to a near flush cut that minimizes or potentially eliminates the secondary sanding step. Because this application involves sawing rather than grinding, structural rigidity was prioritized in the setup. A high-power PushCorp robotic spindle was paired with a 10-inch carbide Walter saw blade suitable for aluminum cutting. A custom adapter allowed the blade to sit closer to the mounting face, enabling tighter cuts near the parent material. During testing, the blade operated at a controlled feed rate and an optimized speed selected to balance stability and material removal. Unlike grinding applications, no force compliance device was used in this configuration. Maintaining rigidity through the spindle and blade assembly was necessary to achieve predictable cut geometry and repeatability. The cutting strategy evaluated during the demo had two steps. The first step involved performing a near flush cut at the gate location. This method reduces the amount of remaining stock and moves closer to eliminating the sanding operation. However, as the cut completes and the part becomes unsupported, a small burr can form near the end of separation. In the second step, a slight angle is introduced during the clearance cut. Adding this angle helps prevent the backside of the blade from contacting leftover gates from previous cuts as the robot progresses across the tree. This adjustment improves consistency when cutting multiple components in sequence and reduces the risk of interference. Cut order also plays an important role. Beginning with lower components allows gravity to assist with part drop rather than creating obstruction during subsequent cuts. In a full production cell, fixture orientation would be designed with this sequencing in mind. The evaluation confirmed that robotic gate cutoff on lost foam aluminum castings is mechanically feasible and repeatable. If the objective is to eliminate sanding entirely and achieve fully flush trimming, it's likely required to use additional sensing such as a vision system. This would compensate for part variation and minor casting warp. The most important takeaway from this demo is that tooling configuration, cut angle sequencing, and fixturing strategy determine whether the system simply separates parts or meaningfully improves the downstream process. For foundries evaluating robotic grinding or gate cutoff, controlled lab testing is often the most effective way to determine feasibility before committing to a full production cell. PushCorp can perform the same cutting process with matching results for any cast material, not just aluminum. Gate removal on cast iron, steel, and stainless steel can be safer for the operator, and it's possible to achieve a near flush cut and potentially eliminate the post-cutting sanding step altogether. If you have an application you're interested in automating, we'd love to help you explore your options. Please send us an email to sales@pushcorp.com.